Okay, today we're going to start with a review of what a parabola graph looks like. If I gave you the parent function y equals x squared and drew my x and my y axis and my x and y table, if I plug in 0, 0 squared is 0, so I'd have the point 0, 0. 1 squared is 1, 2 squared is 4, 3 squared is 9. Negative 1 squared is 1, negative 2 squared is 4, negative 3 squared is 9. So I'd have the point 0, 0, 1, 1, 2, 4, 3, 9, 1, negative 1, negative 2, 4, negative 3, 9. And there's my parabola. So remember we did this a couple weeks ago when we were talking about the shift. So if I'm starting at the vertex, wherever the vertex is, as long as I don't have any stretch or shrink, I'm going to go over 1, up 1, and make a point. Out 2 or over 2, up 4, over 3, up 9. If I went out 4, I would go up 16, 5 would be 25, and so on. Okay, if I have a stretch or a shrink, it just changes the y values by multiplying the stretch and the shrink to that amount. Okay, so we're going to think about that today when we're graphing. All right, but we're going to start with what is a quadratic function in general form. Usually we're going to call it standard form. I don't know why these notes like general form, but usually you'll see it in standard form. Standard form is ax squared plus bx plus c. Okay. Has the parent function, and that would be equal to y. You'd set it equal to 0 if you were solving. Has the parent function of y equals x squared, because then everything else is 0. B and c are 0. The shape of a graph of a quadratic is a parabola. It can open up or down, but remember a parabola is a U when it's the normal parent graph. Okay. If A is greater than 0, the graph opens up. Up. If A is less than 0, the graph opens down. The vertex, if the graph opens up, is at the bottom of the graph. So right here, so your vertex is a minimum. If the graph opens down, the vertex is at the top of the graph, so it's a maximum. Your formula for vertex is negative b over 2a. That's how you get the x value. And then you're going to plug that x value in to the equation given to get the output, to get the y values. Your axis of symmetry is x equals negative b over 2a, whatever this number is, always x equals. The y-intercept is 0c. C is the last number in that general form. You can only get it by looking without doing any work if it's in general form. Every other form we have to solve for the y-intercept. The x-intercepts can be called roots, zeros, or solutions. And to find the x-intercepts, we will factor, use our square root method, or we will use quadratic formula, whatever we need. Okay. When we're talking about the minimum or maximum value, we're going to write this as a y equals equation. So you're just going to take the y from the vertex. So on this first example right here, my vertex is 1, negative 1. And I would say that's a minimum value at y equals negative 1. On the second example, my vertex is 1, 1. It's flipped, so I have a max, and I would have a max at y equals positive 1. Okay, so let's see how this works with an example of an equation and everything we would have to solve for. A is 1, B is negative 4, C is 1. It opens up because A is positive. My axis of symmetry, my vertex, and my range, and what the max or min is I need my vertex 4. I know my y-intercept is 0, 1. Just grabbing that last number in standard form. It opens up, so I know I have a min, but I need the vertex to figure that out. And a parabola is always negative infinity to positive infinity. So let's figure out our vertex. Negative b over 2a is a negative of negative 4 times 2 times 1. So 4 over 2 is 2. That's the x value of my vertex. To get the y value of the vertex, I take that and I plug it back into my equation. So I would have 2 squared minus 4 times 2 plus 1. 4 minus 8 plus 1, negative 4 plus 1 is negative 3. So my vertex is 2, negative 3. My axis of symmetry is x equals 2. My min happens at y equals negative 3. Because it opens up, my range starts at the negative 3 point and goes to infinity. My roots I cannot get by factoring because I have no factors of 1 that add up to negative 4. So I'm going to have to use quadratic formula to solve. So x equals a negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So x equals positive 4 plus or minus 16 minus 4, which is 12. 4 plus or minus root 12. 12 breaks down to 4 and 3. So I get 4 plus or minus 2 root 3 over 2. And I can reduce at the v right here. So I'd get 2 plus or minus root 3. Those are my roots. I do not have to write it as an intercept because it didn't ask for that. Okay. I am going to plot my vertex at 2, negative 3. And then I'm going to do those shifts we just talked about. Over 1, up 1, because I don't have any stretch or any shrink. Out 2 from the vertex, up 4. And there is my y-intercept, 0, 1. Out 3 from the vertex, up 9. So this is 4, so 5, 6, 7, 8, 9. And there's my graph. So you don't need this XY chart unless you just want to plot points. All right. I recommend you try this one by yourself and then come back and see if you did it right. A is negative 1, B is negative 2, C is 7. It opens down. If it opens down, that means I have a maximum value. My domain is negative infinity to infinity. And everything else I need my vertex for except the roots. We'll have to use quadratic formula again. So my vertex, negative b over 2a, it's a negative of negative 2 over 2 times negative 1. So 2 over negative 2 gives me negative 1. Plug in that negative 1. Now notice the only thing squared here is the negative 1, not the negative out front. So I'm going to have a negative of negative 1 squared minus 2 times negative 1 plus 7. Negative 1 squared is 1. 1 times a negative is negative 1. Positive 2 plus 7. Negative 1 plus 2 is 1. 1 plus 7 is 8. So my vertex is negative 1, 8. Axis of symmetry is x equals negative 1. My y-intercept straight from the equation, 0, 7. My max is at y equals 8. And because it's flipped, remember your range is flipped, so negative infinity to 8 with a bracket. My roots, x equals a negative b plus or minus b squared minus 4 times a times c, all divided by 2 times a. X equals 2 plus or minus 4 plus 28 over negative 2. 2 plus or minus the square root of 32 over negative 2. 32 breaks down to 16 and 2. So that's 4 root 2 over negative 2. And then I can divide everything by negative 2, or just 2 if you want to do it that way first, and then we'll go back and adjust the negative. So if I divide everything by 2, I'm going to get 1 plus or minus 2 root 2 divided by negative 1. And then if I divide 1 by negative 1, I get negative 1. A positive divided by a negative makes it negative. A negative divided by a negative makes it positive. So I keep the plus or minus 2 root 2. So my roots are negative 1 plus or minus 2 root 2. My vertex is negative 1, 8. No stretch or compression, but I'm going down. So I'm going to go over 1. Oh, negative 1, 8. Sorry, I did that wrong. Negative 1, 8. Up here, positive 8. Negative 1, 8. Over 1, down 1. Out 2, down 4. Out 3, down 9. So 5, 6, 7, 8, 9. And on this one, I can actually do 16. So I'd go 10, 11, 12, 13, 14, 15, 16. Out 4 from the vertex and down 16. Oops, curve that. And there's my parabola. Sorry. Okay. Okay. The second form that we can look at quadratics in is called intercept form. It's already factored. If you notice, A is still your stretch or your compression. And here are my factors. The root of x minus p is p. The root of x minus q is q. It's the same as we've always done. They're just naming them p and q to show that you're in a quadratic equation. When the quadratic has been factored, you will graph using the x-intercepts as your base points. The x-intercepts will be p, 0 and q, 0. My vertex I'm going to get by adding p and q together and dividing by 2. And then I'm going to plug that number in. That's my x value. Plug that x value in to get the y, just like we did on standard form. My axis of symmetry is going to be the x of the vertex, so you'll add your 2 roots and divide by 2. The y-intercept you have to solve for, so y-intercept you plug in 0 and solve. And the graph opens up if a is greater than 0, and it opens down if a is less than 0. This is just saying a is positive and a is negative. All right, so on the graph, y equals 2 times x minus 5, x minus 1. It's in intercept form because I have factors. The root of x minus 5 is 5. The root of x minus 1 is 1. So my roots are 5 and 1. And that means I have points at x equals 1, x equals 5. It opens up because a is positive. I do have a stretch here. And I'll need to figure out my vertex. So I'm going to add my p and my q together. I'm going to say 5 plus 1 is 6. Divide by 2, and that's 3. That's the x value of my vertex. So 3, comma. I'm going to plug that 3 back in. 2 times 3 minus 5 times 3 minus 1. Just plugged it in for the x of the equation. 3 minus 5 is negative 2. 3 minus 1 is 2. 2 times negative 2 is negative 4 times 2 is negative 8. So I get 3, negative 8. Axis of symmetry is x equals 3. Because it opens up, I have a min. Sorry about that. I have a min. The min happens at y equals -8. My domain is -infinity to infinity, and my range is going to be -8 with the bracket to infinity. The y-intercept is what I need to solve for now, and I let x equal 0. So 2 times 0 minus 5 times 0 minus 1. These parentheses do not equal 0. 0 minus 5 is -5. 0 minus 1 is -1. 2 times -5 times -1 is positive 10. So my y-intercept is 0, 10. My vertex is 3, -8. My shifts, I have a stretch now, so I'm going to go over 1, up 2, because 1 times 2 is 2. Over 2, up 4 normally, but now I need to go 4 times 2, so I'd go up 8. Over 3, up 9 normally, but 9 times 2 is 18. Okay. So here's my vertex, over 1, up 2. Out 2, up 8. 1, 2, 3, 4, 5, 6, 7, 8 gets me right on my x-intercepts. And I'm going to go up to 18. So if this is 8 from the vertex up, then 10 makes it 18. So I'm at the very top, and there I am also on my y-intercept of 0, 10. So there is this parabola with a stretch of 2, vertex at 3, -8. Example 4, in intercept form. My roots are -1, my roots are 3, so -1, 3. Plot those points, -1, 3. It opens up, which means I have a min. I need to figure out what my vertex is. -1 plus 3 is 2. 2 divided by 2 is 1, so the x of my vertex is 1. Plug that in. 1 plus 1, 1 minus 3. 2 times -2 is -4, so my point is 1, -4. Axis of symmetry is x equals 1. I have a min at y equals -4. My domain is -infinity to infinity. It opens up, so I start at my -4, the y of my vertex, and go to infinity. My y-intercept, let x equal 0, so 0 plus 1 times 0 minus 3. 1 times -3 is -3, so 0, -3. Vertex is 1, -4. No stretch or compression, over 1, up 1. Out 2, up 4, so there I am on my intercepts. 1, 2, 3, 4. Out 3, up 9, 5, 6, 7, 8, 9. And that's all I'm going to get on this graph. You can fill your graph. You fill your graph with points. Okay. And that's intercept form. All right. Last form is vertex form. We're going to review real quick with what our shifts are. This should be reviewed, but just in case not, let's go through it. Y equals x squared plus 2. I don't have any left or right movement because I don't have any parentheses. Just the plus 2 means my graph goes up 2. So same thing on number 2, no left or right, but this time I would go down 5. Now I have parentheses, so I do have left and right shift. I'm going to take the root of x plus 5, which is -5. I'm standing at the vertex, which on a parent graph is 0, 0. And negative values are to the left, so I'm going to go left 5. X minus 3, the root is a positive 3. If I'm standing at the vertex, positive numbers are to the right, so I'm going to go right 3. The negative flips or reflects over the x-axis. y equals 2x squared gives me a stretch of 2. Remember, I'm going to multiply the y values by 2. Here I have a shrink of a half, so I would multiply the y values by a half. And then number 8, I have two things going on. The root of x minus 5 is 5, so I'm going to go right 5. And the plus 3 makes me go up 3, so my new point is 5, 3. That's my new vertex. All right, vertex form is y equals a times x minus h squared plus k, and yes, you need to know that. The vertex is at hk. You take the root of x minus h, that's just positive h, and k. The axis of symmetry is x equals h. The graph opens up if a is greater than 0, down if a is less than 0. If the absolute value of a is greater than 1, there is a stretch. It's a vertical stretch, multiplying the y values just like we set up here. If the absolute value of a is less than 1, so something like a half, 2/3, 6/7, there is a shrink or a compression. We've been writing this as a between 0 and 1, and that's exactly what they're saying right there. So either way would be the correct way to write it. And your y-intercept, plug in 0 and solve. All right, so on this equation right here, y equals -2 times x plus 4 squared minus 7. Take the root of x plus 4 is -4. Bring down that -7, and there's my vertex just like that. I have a stretch of 2, and it's flipped. And we're going to answer the questions like we did on the other equations. So if my vertex is -4, -7, my axis of symmetry is x equals -4. It opens down, which means I have a max. The max happens at y equals -7. My domain is -infinity to infinity, and my range is -infinity to -7 with the bracket because it's flipped. My y-intercept, I need to let x equal 0, so I'd have -2, 0 plus 4 squared minus 7. 0 plus 4 is 4, 4 squared is 16. -2 times 16 is -32, and -32 minus 7 is -39. So my y-intercept is 0, -39. Obviously, we won't graph that. My shifts from the vertex would be over 1, down 2. Normally 1, but 1 times 2 is 2. Over 2, normally down 4, but now I'd go down 8. Over 3, normally down 9, but now I'd go down 18. Because this graph is starting so low at -4, -7, I'm not going to get but one extra point on there on each side of the vertex. I'm going to go over 1, down 2. And if I went out 2, down 8, I'd be way down on the graph. So we're not going to do that. Okay. Now on the transformation table, you do not have to use a transformation table to graph when you're doing the shifts, but you do need to be able to fill in the top right here for sure. Remember, the only thing that affects the x is what's in parentheses, and I'm going to root it every time. The root of x plus 4 is -4. So this just becomes x minus 4. -2 is the stretch. Well, the negative is the flip. The 2 is the stretch, and that's a multiplier. So you're going to have -2 times y. And then you're just going to put the -7 at the end. So you need to be able to set up the top of the transformation table every time. Now if they give you points and ask you to fill it out, what you would do is then take your x value, plug it in, You get -5. -1 minus 4 is -5. 0 minus 4 is -4. 1 minus 4 is -3. My y values would plug in over here, so -2 times 1 minus 7 is -9. -2 times 0 minus 7 is -7. And then back to 1 again, so I get -9. So my points would be -5, -9, -4, -7, and -3, -9. Those are exactly the points I have. Okay. And that's how that works. All right. Another example of using vertex form would be y equals -2x squared. If you notice, I have no parentheses, so there's no left or right shift. There's no plus or minus the number out here. So my vertex is 0, 0. This does open down, which means I have a max, and that would happen at y equals 0. My axis of symmetry is x equals 0. My y-intercept is 0, 0. My roots, where I'm on the x-axis, is 0. Remember, we always have 2, so you can list it out as 0, 0, 0, or 0 double root. Domain, -infinity to infinity. Range, -infinity to 0 with the bracket. Stretch of -2, so starting at 0, 0, over 1 down 2, over 2 down 8, 1, 2, 3, 4, 5, 6, 7, 8, and then everything else would be off the graph. So your parabola is done. On my transformation table, nothing is changing the y. Nothing is changing the x. I have no parentheses, so x stays. This is a multiplier to the y, so -2y is all I have. And then you would just plug in your values. And -2 times 1 is -2. -2 times 0 is 0. -2 times 1 is -2. Remember, you don't have to fill these out unless you're told to, but this you always need to. Okay. All right, last one on these. My root here is -3. So -3, 1 is my vertex. That means my axis of symmetry is -3. X equals -3. It opens up because A is positive, +1, so no stretch, no shrink. I'll have to solve for my intercept, and I'll have to solve for my roots. I know since it's opening up, I have a min at y equals 1. Domain is -infinity to infinity, and my range is going to be bracket 1 to infinity. My y-intercept, let x equal 0. So I'd have 0 plus 3 squared plus 1. 0 plus 3 is 3. 3 squared is 9. 9 plus 1 is 10. So my y-intercept is 0, 10. My vertex of -3, 1. No stretch, no shrink, so over 1, up 1. I don't know why I can't graph today, sorry. How about -3, +1? Not -1. -3, 1. Over 1, up 1. Out 2, up 4. Out 3, up 9. Up 10, up 9, sorry, it gets me to 10. That's what I'm trying to say. Out 3, up 9 gets me at 0, 10, which is my y-intercept, and there's my graph. Okay. If you notice, we're not touching the x-axis at all. I start at -3, 1, and so since I'm going up, there's no touching, no crossing the x-axis, which means my roots are going to be imaginary. So I'm going to use the square root method to solve. I could use quadratic, but it would be much longer. So I'm going to say 0 equals x plus 3 squared plus 1, just setting my equation equal to 0. I'm going to minus 1 because now the square is isolated, so I can square root both sides. the negative comes out as I plus or minus and square root 1. Square root of 1 is 1, so I really just have plus or minus I, and I'm going to minus 3, and so my roots are negative 3 plus or minus I. Remember, we write the number at front and the imaginary part at the back, the real number at front. Okay. If I was going to set up the transformation table, the only thing that affects the x is what's in parentheses. So that would be x minus 3 and then the y plus 1. And then you would just plug in your values if you needed to do that. Okay. All right, the last part of this note is converting from vertex to general form, standard form. Y equals x minus 1 squared, quantity squared plus 2 means I write it twice. And FOIL, don't distribute that exponent. X squared minus 2x plus 1 plus 2. So x squared minus 2x plus 3 is your standard form there. I got 2x by going 1 times x times negative 1 is negative 1x, and I have another negative 1x to make a negative 2x. Negative 1 times negative 1 is positive 1. On D, I have a negative of x minus 7 times x minus 7 plus 10. You can distribute the negative to the first parentheses only, or you can FOIL first and then distribute the negative. I usually FOIL and then distribute, so I'm going to keep that negative and FOIL, and I get x squared. X times negative 7 is negative 7x, and I have 2 of those, so it doubles to negative 14x. And then negative 7 times 7 is positive 49. I'm going to distribute that negative, so I get negative x squared plus 14x minus 49 plus the 10 that was there. So my final answer is negative x squared plus 14x minus 39. All right, let me know if you have questions.